Water is our most precious resource. This amazing molecule is what makes life on Earth possible. Our own bodies are composed of approximately 50% water. The surface of our planet is 3/4 covered by water, and that's just surface area. If you think in terms of the living space on our planet, what's known as our biosphere, then our oceans, rivers, and lakes represent more than 99% of our biosphere. All of our major civilizations have been formed along waterways, along ports and rivers. We know that any place that we have abundant and healthy water, we have abundant and healthy life. And where we have unhealthy water, we have devastation. And unfortunately, we're seeing far too much devastation these days. Back in the 60s, when the Cayuga River caught on fire, this led to the formation of the Environmental Protection Agency, and efforts were made to shut down point source pollution that was fouling our waters throughout the land. But point source pollution is not our only problem. We have another very big problem, and that is non-point source pollution. This is rainwater and snowmelt that carries pollutants off the land, off of farmland in the form of nutrients and pesticides, off of feedlots, sediment from deforestation, and a toxic cocktail of chemicals that runs off of our streets and parking lots every time we have a rainstorm. The result has been devastating to aquatic ecosystems. We have dead zones now, hundreds of them, nationwide and worldwide, places where nothing can live because there is insufficient oxygen. Basically, the only things that survive are jellyfish and bacteria. There's one at the base of the Mississippi River now that's the size of the state of Connecticut. We also have red tides, these blooms of algae that produce toxins, and animals showing up with terrible tumors like this turtle, or fungal infections like these dolphins that are covered with a lobomycosis, something that humans could actually get. Clearly, this is a clear indication of how devastated our waterways are. This unhealthy situation is what led to the formation of the Ocean Research and Conservation Association, which was founded in 2005 by myself and Keith Paglin. And we are dedicated to developing technological solutions to ocean conservation challenges. So one of those challenges has to do with the way we figure out what's going on in our water. The primary way that we know about the state of our waterways is by hand samples. But if I go out and I take a hand sample and I come back and tell you there's something really bad in this water, well, did you take it there or did you take it there? You're not going to be able to know what that sample means unless you can be able to determine where the water was coming from and going to. So the problem is we need real-time monitoring, but monitoring costs way too much money to do it on the scale that we need it. So our emphasis has been on developing low-cost monitoring systems that we can put out in large numbers in our ecosystems. And we call the character, or the instrument that we've developed, Kilroy, after that Uber GI of World War II fame that was always there first. So the idea behind Kilroy is to develop a low-cost system and design it the way you design a cell phone, so that everything is in one place, using one power supply and one communication system. It's wireless, it's easy to install, it's low cost, and the idea is to have them everywhere. They'll be on dock pilings or channel markers, as you see here. Kilroy is under the water, and then Kilroy's voice is at the top of the piling and communicates to shore through cell phone technology. And we've designed this to be as easy to install as possible. We originally had a system, as you'll see on the next slide, where it was attached on to an existing dock piling through a series of clamps. We now have everything attached to what we call Kilroy's hat rack, so the whole thing can go in the water in less than half an hour and nobody has to get wet. And we measure a whole range of parameters that scientists are interested in. Two of particular interest are flow, speed, and flow direction. This has to do with figuring out where the pollution is coming from and going to. Another one of interest is bioluminescence. Now, most people don't realize that bioluminescence is so common in the oceans, but out in the open ocean environment, from 1,000 meters to the surface, 80 to 90% of the animals out there make light. and they use it to help them find food, attract mates, and defend against predators. In the coastal zone, there aren't quite as many species, but they can occur with huge numbers. So you can have blooms where you get something like you see in this next little video of a dolphin swimming through bioluminescent plankton and exciting the plankton as it goes. So we can get these huge blooms of plankton, and we can actually identify animals by the type of flash they produce. So this is a really useful tool for figuring out what's going on in these ecosystems. For example, we can identify this dinoflagellate, and all of the dinoflagellates, in fact, that produce paralytic shellfish poisoning. Or this jellyfish that was the same jellyfish that when it was accidentally introduced into the Black Sea ended up collapsing the fisheries there. These have very different flashes, and we can identify them. So the goal here is to be able to figure out the pollution sources and sinks. So you have a situation like this where you have multiple potential sources, one from a community, from a golf course, from a factory farm. And all of these are feeding into the same waterway, so if you try to clean up the pollution, what you end up with is just a whole lot of finger pointing with everybody saying, well, it's not me, it's him. With Kilroy's in place, now you can start to identify where those sources are coming from and figure out what you need to do in order to mitigate the problem. So the concept here is the same one as when we had the Clean Air Act. Once the Clean Air Act was instigated and we had the means to monitor, figure out who the polluters were, then we began to clean up our skies. Well, we have a Clean Water Act. What we don't have is the way to mitigate in order to be able to figure out where the pollution is coming from. But with Kilroy in place, now we can actually be watching 24 hours a day, 7 days a week. So for example, here in this next little video, what you'll see is a rainstorm coming in over this factory farm and overflowing the banks of what they euphemistically call a lagoon, where they hold the manure. This floods into the waterway during this rainstorm, and now we can be there with Kilroy to be able to take a water sample that's triggered because it sees that turbidity front coming through. It calls our cell phones, tells us that it's taken that water sample, and now we can call an EPA certified lab and they can go out and take that sample, and we have a chain of evidence that makes sense. So that now we can bring up substantive change. But a big part of this is being able to make the public aware of how they can bring about change. And so that means that we have to convey this information in a way that they can understand. So right now we're doing it with a fairly intuitive web interface where each one of these arrowheads is a Kilroy, and the arrow is pointing in the direction of the flow, and the length of the arrow is proportional to the flow, and the gauges down the side of the screen provide information about what the different parameters are that are being measured. But eventually we'd like to make this as intuitive as a weather map. You go to that weather map and you know instantly that where red is hot and blue is cold. Well, we'd like to do the same thing with pollution. Red is bad, blue is good, and now you have a real-time capability of being able to see what's going on in your favorite waterway. So in this case, what you're going to see is a little pollution event, and this is an artist's rendition. So what we've got is Kilroys up and down this tributary, and we click on this one Kilroy, and now you get a readout on the side of the screen that shows you what that Kilroy is reading, plus you get interpolation between Kilroys so that you can see kind of overall in that color code that I mentioned earlier of what the quality of the water is. Now if you want to put in the Kilroy's serial number and a start date and time and a stop date and time, now you can run a high-speed animation and see, for example, what's been happening over the last 24 hours. So if we click on Animate and then look at this, you'll see a pollution event at this little tributary here that it carries down, and although the water is flowing from north to south, you're going to see that as the pollution comes out, it's actually going to flow against the flow to the north because it's being a wind-driven event. It's on the surface waters. So this is just an example of how complex water flow patterns can actually be, and how Kilroy can actually start to be able to deal with this dynamic nature of water and be able to tell us where the pollution is coming from and going to. And now we have a chance to really protect our planet's most precious resource, which is water.